Let's talk about BubbleSort. BubbleSort sorts a list by repeatedly swapping two adjacent items and comparing them. So with this example, first it will compare these two items and say, hey, is 3 less than 6? Yes, so we don't have to swap them. All right, then it's going to go to the next pair. Is 6 less than 5? No. All right, so we should swap it. Here, 4 should go on the left. Here, everything's good, so we don't need to do anything. Here, we should swap because 8's bigger than 7 and 8's bigger than 2. Okay, so that was the first loop. Now, you should notice that by doing that one loop, we made the biggest item in the list on the right. The biggest item bubbled up the list to the right. Okay, so now we're going to go for our second pass. This is good. Here, 4 should go less than 5. Here, 1 should go here. This is already good. This is already good. Here we should swap. All right. Now you can notice that the second largest item bubbled up to the top. Why? Because if you had an item here, which is the largest out of this list, then it's going to always swap to the right when you're comparing it. So it's always going to swap until there's nothing left to swap with. So that's why you always, in each iteration, bubble up the, for iteration k, you bubble up the kth largest item. All right, so let's continue. This is good. Here we should swap. This is good. This is good. Here we should swap. Now the first 3 items are in the right order. The first 3 largest items, or the last 3 items. All right, here we should swap. This is good. This is good. We should swap. All right. This is good. This is good. We should swap. This is good. This is good. Or this we should swap. All right. This is good. This is good. This is good. So that's what BubbleSort would do. Okay, so let's talk about the code. What we do is we compare 2 items. So if the jth item is bigger than the j plus first item, if the left item is bigger than the right item, you know you should swap them. And that's what this does. It swaps them. The j item becomes j plus first item, the j plus first item becomes the jth item. In order to loop correctly, we start at the beginning, at 0, and we go up to as far as we need to go. Now, this is for a little bit of time computation saving. We only go up to the length of the list -1 minus I, because if you notice, on the ith pass through, the last I items are already sorted, right? So after we did 1 pass through BubbleSort, 8, the biggest item, was at the end, and then after we did 2 passes, 7 and 8 were at the end. So the last I items are already in the right place, so we don't need to do any swaps there. So that's why we go to the length of the array -1 minus I. So basically, this outer I loop will make the ith largest item bubble to the end, and then the j loop ensures that we do the pass through the items to make it bubble up outward. Okay, so here is the running Python example. We take the list, we run BubbleSort on it, and we get the right output. And for sake of completion, here is the C++ version, which is the exact same logic, except you can't use that fancy swapping notation in Python, but you have to store the temporary variable when you're swapping. And then here it is in C++ running. Okay, so let's talk about correctness and runtime. So first of all, why is it correct? Well, if in the ith pass through, we are making the ith largest item go to the back, then we're going to have the largest item in the back, the second largest item is the second largest, the third largest item is the third largest, the fourth largest item is the fourth largest. So if we do that for the whole list, then the list must be sorted. That's why it's correct. Now let's talk about runtime. This outer pass is going to do O of n loops. And the j is going to go O of n as well. So therefore, it's going to be O of n squared worked, because everything in here is just O of 1. So if we have O of n times O of n times O of 1, we're going to get O of n squared. I made a function to simulate the runtime by basically passing in a bunch of different lists, and it creates a graph that shows on the x-axis the size of the list, and the y-axis how many milliseconds it took to sort that list. As you can see, this is a parabola, so this confirms through test results that it is O of n squared in runtime. All right, that's it for BubbleSort.